Okay, so this section of work has to do with completing the square, and this is a method of solving trinomials that seem unsolvable by means of factorization and by means of using your square root. So the wording here suggests that the square is incomplete and you have to complete it. The square in question here is referring to perfect square trinomials. Okay, I'm just going to draw a square. Perfect square trinomials, right? And these are trinomials, quadratic trinomials, that look a certain way. So some examples of perfect square quadratic trinomials includes x squared plus 2x plus 1. That's one example. Another one is x squared plus 4x plus 4. And another one where we have a bit of a sign change is x squared minus 6x plus 9. Now we're going to spend a minute looking at these perfect square trinomials because they have a certain structure that makes them perfect square trinomials. Okay, so for all of these guys, you'll notice the coefficient of x squared is 1. So that is one quality. Let me just remind you, quadratic trinomials take the form ax squared plus bx plus c. So the a value is 1, right? The most important thing, however, is the relationship between b and c. B and c, b and c. And that is how you can formulate a perfect square trinomial with just the a and the b value. So let's look. Here's my c value, all right? And that c value can be obtained by saying b over 2 squared. Let's try it. We go 2 over 2 squared, which gives us 1. So there my perfect square trinomial is complete. Of course, we know that because it was complete in the start. Let's check this one. We go b over 2, 4 over 2 squared, which will give us 4. So that's a perfect square trinomial. And we go for the 9, we say minus 6 over 2 squared. Positive or negative doesn't matter because we're squaring it, so it will be positive, and that gives us 9. Okay, so now let's get to the perfect square trinomials and how to write them out. Okay, so taking the first example over here, right, we have x squared plus 2x plus 1. The criteria is met. Okay, the coefficient of x is 1. All right, and the c value we get by saying b over 2 squared. So this is a perfect square trinomial. And now to factorize this trinomial very quickly, you're going to take a set of brackets. You're going to square the brackets. The sign on that bracket comes from your b value, so positive, and the values that go in that bracket is the square root of the first term, which in our case is x, and the square root of the last term, which is 1. And so now this perfect square trinomial factorized very, very quickly because of its unique structure. All right, and that is what we have to do. We will be given the a value and the b value, and then we have to calculate a c value so that we have a perfect square trinomial that can be factorized the way I just did. Let me do this last one as well so that you see what happens with minus. So we have x squared minus 6x plus 9. This is a perfect square trinomial. The a value is 1. The c value we got by saying b over 2 squared, as I proved over here. Okay, so we open our set of brackets. We put our square. The sign comes from b, so here's a minus sign. We square root the x to get the x squared to get x. We square root the 9 to get 3. And then we factorize this perfect square trinomial within seconds. We now proceed to an actual example. The instruction is to solve for x, and I would say to you, leave your answer in third form. Now when that wording is used, that tells you to complete the square, because when we complete the square, we end up with a solution that has a third. All right, so if we look at our specific problem over here, we have x squared minus 4x plus 2. Alright, we have our a value equal to 1, so I'm happy with that. I have my b value equal to minus 4, and this guy is kind of out of place. I don't want that number. I want the proper c value. Okay, so your first step is to get that 2 out of your way, because he is not going to give you your perfect square trinomial. So we go x squared minus 4x is equal to negative 2. Now at this point, we are going to introduce a number that is not supposed to be there, but at the same time we're going to get rid of it. So I want the c value, right? Because that is going to allow me to factorize this incomplete trinomial on the left. So, as shown above, to get the c value, we say b over 2 squared. Our b value is minus 4 over 2 squared, which will give us an answer of 4. So what I'm going to do is I'm going to add the 4 on the left, but then I'm also going to undo my actions by adding it on the right. Okay? When I do it on both sides, I cancel out what I did. So what you do on the one side, you do on the other side, so that you are equally unfair. Now what we're going to do is we are going to simplify. What I have on the left is the perfect square trinomial that I wanted, right? So I'm going to open up my brackets, put my square there. The square root of x squared is x. The sign comes from the middle term, which is negative, and the square root of 4 is 2. So the left-hand side is now factorized. Then on the right-hand side, we have minus 2 plus 4, which is 2, right? And now at this point, we can solve for x very quickly because we know how to get rid of a square. So what we now do is we square root both sides to get rid of the square. So we're going to square both sides so that we're left with x minus 2 equal to plus minus root 2. Okay? Now when you're going to square root the value on the right, it's important to add the plus minus so that you include the positive and negative solution. Right. So we are one step away from having the answers for x. We just need to subtract or add the 2 on both sides. So therefore x is equal to positive 2 plus minus the square root of 2, and that is the answer to this specific problem. Now if you're wondering why I put the 2 first, it's just preference. You could have left it as is, alright, and it still would be correct. So again, you want to have on the left hand side, so there's the left and here's the right. On the left hand side, you want to have your perfect square trinomial, okay? And once you have that, it's just a matter of solving for x, right? We introduced a new value that wasn't initially in our sum. So we manipulated this problem to our liking, to our needs. But it's okay because I added it on both sides. Once I introduced that unknown element, we were able to nicely factorize our perfect square trinomial. And from there, it's just a matter of solving for x. And as was requested in the question, this answer was left in third form. So we are done.